Just as in the case of sentential logic, in predicate logic there's a set of logical properties that you can establish by means of models or interpretations, and there's another set of properties that are established by means of derivations. As a matter of fact, these properties are exactly the same as those we already saw in sentential logic, and everything that you learned there can be applied here. So, to refresh your memory, validity, logical truth and falsity, equivalence and inconsistency were established by means of derivations, whereas invalidity, contingency, inequivalence, and consistency required using examples. Let's start with the first group. Since we've already dealt with validity, we're going to review contradiction, also known as logical falsity. Remember that to show that a sentence is contradictory, we start from that very sentence as a sole premise, and then we proceed to find both x and not x for any sentence x. In other words, if you start an argument with a given sentence y as the only premise, and you validly reach both an arbitrary sentence x and its denial, then y itself is contradictory. Let's give an example. Let's show that this sentence is a contradiction. To do so, we start a derivation and place the sentence in question on line 1. But notice that the only way to make any headway here is by driving the negation inwards. Otherwise, we can't exploit the quantifiers in the sentence. So we have to do it step by step. We have two quantifiers, and we want the negation to be within the scope of both of them. So we have to apply qn twice, once for each of the quantifiers. So on line 2, our application of qn results in a change of quantifier from universal to existential, and in the movement to the negation sign to the right of our new quantifier. Once we do the changes, we write that this was by quantifier negation line 1. On line 3, we repeat the procedure. The negation gets pushed to the next slot available to the right, and the quantifier goes from existential to universal. The justification is qn on 2. So now, in line 3, the negation is in front of the body of the sentence, and we have an existential quantifier that is ready to be exploited. To exploit this quantifier, we need to open a subderivation. So let's pick the first name that comes to mind. Let's say A, just to keep things interesting. The assumption, and pay attention here, is going to be a substitution instance of the existentially quantified sentence that we want to exploit. So if you remember the procedure, what we do is that first we get rid of the quantifier at the front, and second we replace all of the occurrences of the variable that was bound by the quantifier, in this case x, with the name A. So on line 4, we write the substitution instance that is going to be our assumption for the purposes of existential quantifier elimination. Now the sentence we have here in 4 is universal, which at this point we can eliminate. And since it is universal, we can eliminate it by using any of its substitution instances. In particular, we can do it with A. So what we are going to write on line 5 is an A for Y substitution instance of the universal sentence in 4. So we eliminate the quantifier, and wherever Y appears, we replace it with A. So in line 6, we are left with not if HA, then HA, by universal quantifier exploitation, line 4. The sentence is the negation of a conditional. And if you remember your sentential logic, there is a rule called conditional that tells us that this sentence is equivalent to this other, HA and not HA, which we write on 6 and justify by the conditional rule, abbreviated as C on line 5. So now I'm going to detach the conjuncts and place them in lines 7 and 8 respectively, and you're going to see why I'm doing this. The reason is that I need to use the contradiction rule, and we stipulated that this rule must take 2 lines as input. So on line 9 I enter the falsum, which marks the contradiction, and I then write CD lines 7 and 8. Now we can close our subderivation because, as you'll remember, our goal was to arrive at a contradiction. So on the next line, I can export the result I obtained in 9. And I say that I got this by existential exploitation, lines 3 and 5 through 9. Let's show that this sentence is a contradiction. Again, the strategy here is going to be to derive both a sentence and its contradiction. But before we start pushing symbols around, let's take a look at the sentence. Notice that it contains both LXY and its direct denial, not LXY. So it's that pair of formulas that is likely going to be the source of the contradiction we're looking for. So let's start our derivation. The sentence we're given is going to be our premise on line 1. Its main operator is a universal quantifier with scope over all the material inside the brackets. So our first step is, unsurprisingly, to eliminate this universal quantifier. In line 2, we remove the quantifier, which is associated with the variable x. And then we're going to substitute all the occurrences of x within its scope with, yes, you guessed it, the letter A. So we end up with a conjunction of two quantified sentences. Every y, L-A-Y, and there is a y, not L-A-Y. We annotate as follows: universal exploitation, line 1. The main operator here is the ampersand, and on the next two lines, we break it apart by ampersand elimination on 2. Now we have two sentences we can work with. One is universal, the other existential. As always, we're going to start with the existential. But we can't deal with the existential without first opening a subderivation. So that's what we do on line 5. I have good news for all novelty seekers out there. We can't use A because it's already in use. So we're going to pick B as a name. And our assumption is the B for Y substitution instance of the existential in 4, which is not LAB. This is our assumption for existential exploitation. Now, in our next line, we are ready to eliminate the universal in 3. We can actually use any letter we want in place of the Y there. However, if we use B, we'll get LAB, which in combination with not LAB, already in line 5, will give us the contradiction we are aiming for. So on line 6, we write the B for Y substitution instance of the universally quantified sentence in 3, which is LAB, by universal quantifier exploitation on line 3. In consequence, lines 5 and 6 give us our contradiction, and on line 7, we write the falsum by contradiction, lines 5 and 6. Now we can close our subderivation, and on line 8, we write the falsum again by existential exploitation, 4, 5 through 7. So here I just illustrated the case of contradiction, but as in this case, the rest of the properties are determined in the same way as we did in sentential logic, so this doesn't introduce anything new. Well, this is all for today. Goodbye.